All right, in this video, I'm going to look at the basics of a series. So, we're going to start off with what is a series? So, a series is just the terms of a sequence, but they're added together. So, a series is very, very similar to a sequence. It's the terms of a sequence. The only difference is instead of listing them all out, we're going to add them all together. For example, right here, 7 plus 10 plus 13 plus 16 plus 19. That is a series, where a sequence would have been 7, comma 10, comma 13, comma 16, comma 19. So what we're going to do is we're going to write this series using summation notation. So we're going to come up, we have our numbers here. We got to come up with the formula or the rule, and we're going to put it into summation notation. I'll talk about what that is when we get there. So probably what we want to start off with is write a general rule on how we get 7, 10, 13, 16, and 19. So we probably want to focus on any patterns we notice, because patterns will typically give you a hint and help you create your general rule. So first thing I notice is going from 7, 10, 13, 16, 19 is we're adding 3 every single time. So we add 3 every single time. So when I come up with my formula and my rule, it's probably going to have a 3 involved. So what I do is I kind of look at, well, which term is it in the sequence? So this is n is 1, n is 2, n is 3, n is 4, n is 5. And what I do is I pick one of the bigger terms, like this one. So I know n is 4, so I'm going to be using n in some case, and I got to make that n of 4 turn into 16. But remember also we had that pattern of 3 every single time. So if I did 4 plus 3, not going to quite get there. 4 plus 3 is 7, not 16, not really going to get us there. What I would try is taking this 3 and let's multiply it by our n. So if I took 3 times 4, I get 12, but I'm 4 short. Over here, if I took 3 times 5, I get 15, but I'm also still 4 short. So what if, we still keep doing that 3n, but let's add 4 to it. So here, and I'm going to try it out before I assume this is right. 3 times 5 is 15, add 4 is 19, so it works here. 3 times 4 is 12, if you add 4 is 16, works there. 3 times 3 is 9, add the 4, you get 13. 3 times 2 is 6, add the 4, you get 10. And 3 times 1 is 3, add the 4, you get 7. So 3n plus 4 is going to be our rule. So what we need to do is we need to write using summation notation. So how that's going to work is I'm going to do summation notation. We're going to use a sigma. And what that means is that sigma means add all the numbers together. And what we do is we put our rule over here to the side, so 3n plus 4. There's only 2 things we're missing, and if you look at my next example, you'll see there's things on top and bottom. What I want is I want to tell it, well, how long does this sequence add? Does it have an ending, or does it going to go in infinite directions? So we started with n equals 1, so I put the starting point on bottom, and I need to put on top, well, where do we end? So is this an infinite and goes on forever and ever and ever, or does it end? Well, as you can see here, we go 7 plus 10 plus 13 plus 16 plus 19, and there's nothing else there. There isn't a plus dot dot dot. So there is an ending, so I need to figure out where is that ending happen. Well, this is the first, second, third, fourth. It happens on the 5th term. So we're going to put a 5 up top. So what this means is it says, in words that you would understand, it says find the sum when n goes from 1 to 5 when we have 3n plus 4. So this is our answer in summation notation. So that's going from a series to a summation notation. On my next and final example, I'm going to go from summation notation to my series. And we're actually going to find the sum and add them all up together. So reading this, I know my rule is 7n, and it says start with n equals 1 to 5. So I'm going to start when n equals 1, you plug it in here. So if you have n equals 1, we're going to end up with 7 times 1, which is 7. When we go from n equals 1, let's now go to n equals 2, because remember, we go to n is 1, all the way up to n is 5. When n equals 2, we're going to have 7 times 2, which is 14. Then we go to n equals 3. So 7 times 3, which is 21. Then we have n equals 4, which is 7 times 4, which is 28. And then we have n equals 5, which is 7 times 5, which is 35. Now I'm going to stop there because that's the highest it wants me to go with n. So I did from n's to 1 to 5. I just plugged in my n values. I got 7, 14, 21, 28, 35. So what this series would look like is 7 plus 14 plus 21 plus 28 plus 35. That's what my series would look like. The only thing that is different here is they want us to actually find the sum. They want us to add all this up together, or just add up this entire column of numbers, which you can do all that by calculator, and that's going to equal 105. So that is the sum. That is basics of a series and the second video of 8.1.